Hello, if you are active on this live class, I want you to put a comment in the comment section. Just say hi in the comment. You're welcome to this live class. In this live class, we'll be talking about circle geometry, as you can see on the board. Circle geometry. There are some theorems that we're going to master in this class that will help us understand circle geometry very well. So we're still trying to put things in place so that everything, you will have a very smooth learning experience. Just a minute. Yeah, sorry about that. We're trying to fix some things. You know, this is the first time I'll be on live on YouTube. So there are some things we are still putting in place. But if you can hear me, I want you to type in the comment section. Just type yes in the comment. If you can hear me, type yes in the comment. If you can hear me, type yes in the comment. Okay, let me confirm from my team if you can hear me. Can you hear me? Loud and clear, right? Okay. Okay. So, like I said before, we're going to be talking about circle geometry. Now, this topic is actually a topic that many students fear a lot. They are not really comfortable, but if you want to be very good at this topic, you must understand the theorems and how they are applied. Once you understand the different theorems, it will be easy for you to know how to apply them. Don't worry, in this lesson, we're going to be looking at the different theorems and also how to apply the theorems. Okay, so before we begin to talk about the theorems, I want us to talk about the parts of a circle. If you don't understand the parts of a circle, you will struggle with understanding or solving problems on circle geometry. So let's start with the parts of a circle. Now we're going to start with, let me just put my center here, center O. Let's start with what a radius is. If I draw a line from the center to any point on the circumference, this is the radius, which means a radius is defined by the line drawn from the center of a circle to any point on the circumference. That is what a radius is. Now, if it is just one like this, it's called a radius. But when you have multiple radius, I'm even use the word radius, when you have multiple lines drawn from the center to any point on the circumference, if you want to categorize them, you will simply say radii. This is the plural of radius. But let's just go quickly because we need to start discussing some of the theorems, some of the circle theorems. Okay, now we've talked about radius. Let's talk about the circumference. So I will also be confirming for my team if they can see what is here. Okay. So when we say circumference, circumference is also perimeter of a circle. A circumference is the distance around a circle. So if I start from here and I go round, complete it, that's what's called a circumference. So a circumference is the distance around a circle. That's what a circumference is. Okay, now let's talk about diameter. What is a diameter? Just as I told you that a radius is a line drawn from the center to any point on the circumference, so also the diameter is a line drawn from one point on the circumference of a circle to another point, but it passes through the center of the circle. So look at what I have now. If I start from here and I draw a straight line, it must pass through the center of the circle. This right here is a diameter. Notice something. If I use D to describe this diameter, to represent the diameter is 2 times the radius. So D is equal to 2R if R here is the radius. When you have a radius, another radius, when you add these two radii, what you have will be the length of a diameter. A diameter is a line that passes through the center of a circle. It divides the circle into 2 semicircles. So from here now, like this from here, this is a semicircle. This is also a semicircle. That is what a diameter is. Okay, now let's talk about a sector. What is a sector? So a sector is an area bounded by 2 radii. You know, I told you that this word radii is a plural form of what? Radius. So let me show you something. Let me just shade where the sector is. Look at this. From here to here, this is a radius, right? Another radius. Now look at what I'm shading now is called a sector. A sector is the area bounded by 2 radii, and not just 2 radii, and an arc. So see, this is an arc, this is a radius, and another radius. What I just shaded now is a sector. Let me say it again. A sector is an area bounded by 2 radii and then an arc. Yeah. Then let's talk about semicircle. If you have any question, put it in the comments. My team will respond and they will get back to me. A semicircle is an area bounded by a diameter and an arc. Let me say that again. A semicircle is half of a circle. See, this what you have here is a semicircle. It's an area bounded by a diameter and then an arc. That is a semicircle. Let's go quickly. What again? Let's talk about a segment. But before we talk about a segment, let's talk about a chord. What's a chord? A chord is a straight line that joins any 2 points on the circumference. So from here to here, this is a chord. If I call this A and B, line AB is a chord. You see, from one point on the circumference to another point, this is a chord. But I did say I was going to talk about a segment. A segment is an area or a portion bounded by a chord. See a chord here, and an arc. Let me show you. It's an area bounded by a chord and an arc. So let's shade this. What I just shaded now is a segment. Don't confuse a segment for a sector. A sector is an area bounded by 2 radii and an arc. But for a segment is an area bounded by a chord and an arc. Okay, there's one I've not really said. I hope it's just one remaining. An arc. An arc. What an arc? I've been using the word arc since. An arc, I told you that a circumference is a distance round a circle. That's a circumference. But for an arc is just a portion. It's just a part of a semi. It's just a part of a circumference. It's not the complete distance around the circle. It's just a portion. So I can describe this right here, from here to here, is an arc. Notice it's not the complete circumference. From here, if I call this C, from A to C is an arc. From C to D is also an arc. So I think I've been able to explain the various parts of a circle. If you truly understand the parts of a circle, you would be able to, it's like a leverage when you want to begin circle theorem. Understanding the various parts of a circle will help you greatly as you begin your learning journey on this topic, circle geometry. If you have any question, please drop it in the comments before we move on to the next aspect of this topic. We're going to be talking about chord properties. So if you have any questions, drop it in the comments. Let me take a few seconds to get water. Can you hear me? Can you hear me? Okay, so for a chord property, let me just write this chord property. As you can see now, this is a chord. Let me just call this AB. This is the chord. If you have a line drawn from the center of a circle, and that line divides this chord into two parts. Let me draw a line from the center to the chord, from the center to the chord. If this line divides this chord into two parts, let's call this M. So if from M to B, so I just discovered that you could not hear me, but sorry about that. I'm back now. Now I just use the word perpendicular. When you hear the word perpendicular, it happens when one line forms angle 90 degrees with another line. See, for example, if you have this and you have angle 90 degrees, these two lines are perpendicular to each other. So if this line drawn from the center to the chord divides the chord into two parts, see, from M to B is equal to from M to A. If that's the case, then the angle formed between this line and the chord is 90 degrees. This is what you need to know about chord properties. Okay? Now let me quickly write another one. I will ask my team if we have space on the other side. Do you have space here? I can write here. Okay. So let me draw another. Maybe I will not have to write the properties because of time. As you can see here, we have two chords, AB and CD. So from this chord property, if chord AB and chord CD are the same, then we can simply say, let me just write the property, equal chords of a circle are equidistant. I will explain what this means. Are equidistant from the center of a circle. So see, if this is the center of the circle, right? It means that from here to here, for example, let's say you have from here to here, the distance from this chord to this center will be the same from here to this. It's not drawn to scale, obviously. So equal chords of a circle are equidistant. So if AB and CD are the same, this is center O now. If they are the same, then they are equidistant from the center of the circle, which means that if chord AB is equal to chord CD, then O, let's call this M, and let's call this N, then ON will also be equal to what? OM. This is what the second chord property is talking about. If two chords are the same, they are equal in length, then they are equidistant from the center of the circle. That's it. Okay, so this is all for we're going to be talking about chord properties. We're now going to go to the angle at the center theorem. Angle at the center theorem. I'm going to clean this now and start from angle at the center theorem. Let me take this off, and then, well, before I take this off, I don't know whether there's any question. Do you understand this chord properties? The first one says, if a line is drawn from the center of a circle and divides the chord into two parts, then the line forms angle 90 degrees with the chord. That's this one here. As you can see, there's 90 degrees here. But for this one, if two chords are equal in length, then they are equidistant from the center of a circle. See what I have here? See what I have here? ON, if AB is equal to CD, that's if the two chords are equal in length, then it means that the distance from the center of the circle to the two chords are the same. They are equidistant. The two chords are equidistant from the center of the circle. These are the properties of a chord. So we're now going to talk about the center of the angle at the center theorem. I'm going to take this up and then we'll get started. If you have any questions, put it in the comment section and we'll answer your question. And if you're enjoying the class so far, just put something on the comment. You can just type yes on the comment. So angle at the center, angle at the center. Before I write down, maybe I will not have to write, or I'll draw a circle. This is a circle. Oh, this circle is funny. So let me make it better. Just manage the circle. Obviously, it's not drawn to scale. So if I have the center from here now, center O, and from this center, I draw two radii. I told you what a radii. I told you what radii are. Plural of a radius. So if I draw two radii from here to here, and from here to here, let's call this M, let's call this N. So from angle at the center, if I put an angle at the center, this O is the center of the circle. If I put an angle here, let's say theta, the angle at the center theorem states that the angle, this angle at the center, subtended by an arc. You know, I told you what an arc is. An arc is any part or portion of a circle. So from here, from M to N is an arc. All right, from M to N is an arc. So if this arc subtend this circle at the center, and the same arc subtend another circle at any point on the circumference, let's say you have it from here, equal to 2 times the same arc, the angle, the same arc subtend at any point on the circumference. So if I have another angle here now, if theta here, or let's call this alpha. So if alpha is equal to 40 degrees, what do you think theta would be? Theta would be what? 2 times 40 degrees. Because the angle at the center subtended by an arc is equal to 2 times the same arc subtend at any point on the remaining part of the circumference. So we're not dealing with this one, huh? If this angle here is formed on any part on the remaining part of the circumference, by remaining, it's not going to be formed from M to N here, but from the other side. So if this arc forms an angle here, or here, or here, wherever it forms an angle, not this side, not this arc, but the other major arc, then the angle at the center is twice the angle this arc subtends at any point on the circumference. And as I've just said now, if alpha is equal to 40 degrees, then theta must be 2 times 40 degrees. What's the reason? Angle at the center. Angle at the center. There you go. So we're going to be looking at some questions on angle at the center. If you have any questions, drop it in the comments and my team will get back to me. But we need to write some questions down. It's time to solve some real questions. Okay, let me take this off. And let me draw the circle. This is P, this is Q, this is R. So O is the center of the circle. So we're asked to calculate angle PCR, angle POR rather, POR. So this is 68 degrees, and this angle here is 50 degrees. We want to find angle POR. Now, where is P? See it here, see point P here, see point Q. But when you say POR, you have to construct a line from point P to the center. The same thing from point Q to the center, because we don't have a visible line drawn from P to O and from Q to O. So we have to construct that. We have to find POR. So let's construct that. But again, we can start by drawing a line from P to O. Let's do that. See? Then another one from here to Q. Now we have POR. Where is it located? See it here. Angle POR. This one here, this angle. So this is the angle we are asked to look for. We're asked to look for. How do we get that angle? Now, for us to get this, I told you about angle at the center, that the angle subtended by an arc at the center is equal to 2 times the same arc subtended at any point on the remaining part of the circumference. Look at this arc here is responsible for subtending the arc at the angle at the center. How do we now get this angle? Now listen, if you are able to get this angle here, this PRQ, then you can easily get angle POR. But again, the question is, how can we get angle PRQ? It's easy. I can already see a triangle. Where's the triangle? Triangle PRQ. That's a triangle. Okay? So I'll say solution from triangle PRQ. Now, what do we know about angles in a triangle? They add up to what? 180 degrees. So it means that when you add, look at this is 68 degrees, this is 50 degrees. When you add 68 degrees to 50 degrees, then to what this one? PRQ, to P angle PRQ. Then they all add up to 180 degrees. And what's the reason for that? Sum of angles in a triangle. Yes, when you add this angle here to this one here, they all add up to 180 degrees. So what is 68 plus 50? That will be what? 118 degrees. All right, plus so 68 degrees plus 50 degrees is 118 degrees plus angle PRQ. and this is equal to what? 180 degrees. Now, since we are trying to get angle PRQ, let's subtract this from both sides. So angle PRQ will be equal to 180 degrees minus 118 degrees. Okay, so what is 180 minus 118? What I can do easily, see, I can just do 118. What will I add to 118 to give me 120? Is it not 2? So I will have 60 what? 2, because this extra 2 added to 60 will give me 62 degrees. So angle PRQ is equal to 62 degrees. Now that we have angle PRQ, it will be easy to get the angle at the center, which is angle P. So I'll say therefore, angle POR will be equal to what now? Remember the angle at the center theorem. It will be 2 times angle PRQ. What's the reason for PRQ? What's the reason for that? Angle at the center. Angle at the center. So what is PRQ? We got it at 62 degrees. And what is 2 times 62? That's what? 4 and then 12. 124 degrees is the angle POR. If you understood what I just explained, just type yes in the comments. Type yes in the comments if you understood what I did. So the first thing I did was to get this angle, and of course this is a triangle. Triangle PRQ is a triangle. So when I got this angle here, it was easy for me to get the angle at the center. Angle at the center, so obtained by an arc, is equal to 2 times the angle at the same arc obtained at any part or any point on the remaining part of the circumference. So the answer here is 124 degrees. We'll look at one more example on angle at the center, and if we still have time, we'll look at another circle theorem. If you are getting value from this video, just type yes in the comments. Type yes in the comments. So we've gotten our answer there. Let's move on to another question. Hope I can clean up. You can take a screenshot. If you are doing so, take a screenshot, and let's move on to another question on angle at the center. All right, thank you. So let's take this off and continue. Okay, we have another center O. Okay, this is X, this is Z, this is Y. O is the center of the circle shown above. Calculate XYZ, angle XYZ. Now, the reason why I have brought out this question is because many students struggle with this. They will tell you the angle at the center is twice the angle so obtained by an arc at the circumference, and they will think that the angle that will be here will be this divided by 2, but that's wrong, because the angle that subtends this, the arc that subtends this angle here is not the same arc that is subtending this angle here. So you have to do something to be able to get angle XYZ. So how do we get angle XYZ? This angle here. Let me tell you something. I want to show you something now. This major arc here, the major because is longer. This major arc is responsible for subtending angle XYZ. See, this major arc is the one subtending this angle here. Okay? this major arc is subtending this angle here at angle XYZ. Now, if you want to get the angle at the center, it is not angle 102 degrees that is being subtended by this arc. No, it's a different arc. This arc you see here is what is subtending this other angle, this angle at the center. So for us to get the angle subtended by this major arc, excuse me, by this major arc, it has to be the reflex of this angle here. So we must get this angle first for us to be able to get this other angle. Can you see now that, see, watch this now. This major arc is responsible for subtending this arc at the center, this reflex angle here. All right. The same major arc is also the one responsible for subtending this angle at this point here, point Y. So don't say this angle is twice this. No, that's wrong. It is this angle, this reflex angle, that is twice this angle here, because they are both subtended by this major arc. As you can see, this major arc from X to Z arc major. Okay. Now we need to get the reflex angle. Now, how do we get this angle here? Angle XOZ reflex. So let's get angle XOZ reflex. Angle XOZ reflex must be gotten first. Angles, the sum of angles at a point is 360 degrees. Let me say that again. The sum of angles at a point, this is a point here, is 360 degrees, which means if I add this angle 102 degrees with this reflex angle, they will add up to 360 degrees. So what am I going to write? For me to get angle XOZ reflex, I will simply say 360 degrees minus what? 102 degrees. 102 degrees. And the reason for that is what? Sum of angles at this point. Sum of angles at a point. Okay, so what's going to be 360 degrees minus 102 degrees? That will be what? 258. 258 degrees. I hope that's right. 102, yeah. 258 degrees. Now that we've gotten this angle now, this 258 degrees, this is 258. How can this help us in getting this angle now? Remember, they are both subtended by this major arc. How will this help us in getting this angle? Easy. Now, because we know that the sum of angles, the angle at the center subtended by an arc is twice the angle subtended by that arc at any point on the circumference. You see, this is a circumference here. The point on the circumference. So what am I going to write? I'm going to say that 258 degrees is equal to, is equal to 2 times angle what? XYZ. X, angle XYZ. The reason for that is what? Angle at the center. Angle at the center. Yeah. So 258 degrees will be, so if I divide both sides, let me just rewrite it again. 2 times 2 XYZ, just to make it, I don't want this to get us confused. So 2 XYZ, that's 2 times XYZ. If I decide to divide both sides by 2, this is 2 and this is Z. All right. If I divide both sides by 2, 2 cancels 2. So angle XYZ will be this divided by 258 divided by 2. So let's divide here. 2 into 2 is 1, 2 into 5 is 2. Remember, 1 into 18 is what? 9. So 129 degrees is equal to what? Angle XYZ. I can just maintain the way I've written it here. So therefore, angle XYZ is equal to 129 degrees. Yeah, this is the answer. So you saw what I did. I had to get the angle subtended by the major arc, first of all, by using sum of angles at a point. Then when I've gotten it, I now use that angle at the center and equated it to 2 times the angle subtended by that major arc at the point on the circumference. Hence, our answer is now 129 degrees. If you understood everything I've said, you can just type 1 in the comments. Just type 1. Type 1 in the comments if you understood what I've done so far. Just a minute, let me speak with a member of my team. Now we're going to do one more circle theorem, and we'll have to reschedule the class for another day. If you have not joined my community yet, make sure you do so you will be notified when I come live. You can just check my bio. There's a link that will take you to either the Telegram channel or the WhatsApp channel. Go there, join the group, and just stay put until I send a message so you'll be notified when I come live. It's important you join my community. Okay, now let's look at another circle theorem, which is the angle in a semicircle. Angle in a semicircle. Now this one is very straightforward, very, very easy. The angle in a semicircle is 90 degrees. And I'll show you how to identify angle in a semicircle. So the angle in a semicircle, the angle in a semicircle is right angle, is a right angle, or is 90 degrees. Either you say is a right angle or you say it is 90 degrees. Let me draw a circle. And then this is the center of the circle. I draw a straight line from here to here. You see that? This is a diameter. Of course, you cannot have a diameter. You cannot have a semicircle without having a diameter. A diameter, like we did when I started, like I said, is a line that divides a circle into two semicircles. So what you have here, see, this is a semicircle. Why this two is a semicircle? Now, how is this useful? Angle in a semicircle. Let me come to the two ends of this diameter. So see, we have these two endpoints here and here. Let's call this A and B. Endpoint A and B, if you draw two straight lines, one from A, one from B, to any point touching, to any point on the circumference. Watch this now. Make sure the two lines, they join. Where the two lines meet, the angle formed is 90 degrees, whether it's here or here. So let's draw from here to here, for instance. So from here to here, you see that? And then from here to here. Oh, this is not well drawn. Let me draw it again. Let's try again. Good. The angle formed here is 90 degrees. So this is what we mean when we say angle in a semicircle is 90 degrees. You see, this here is a semicircle. You see that? From the end point of a diameter, if you draw two lines touching any point on the circumference, the angle formed is 90 degrees. The same thing applies to if I from here draw another straight line and from here join it, the angle formed is 90 degrees. Hence, the angle in a semicircle is what? 90 degrees. Now, let me tell you how this relates so much to the previous circle theorem. You know that previous circle theorem, I did say that the angle at the center subtended by an arc is twice the angle, the same arc subtended at any point on the remaining circumference, on the remaining arc rather, or on the remaining circumference, same thing. See, you can also sort of relate that here too. This is the center of the circle, right? Good. If, of course, the angle on a straight line is what? 180 degrees. So if this is 180 degrees, you see this? You will agree with me that 90 degrees is what? Half of 180. So can you see how this is related to the previous theorem? Again, the angle at the center is 180, and it is twice the angle subtended by this arc here. You see, it is this arc that subtends this angle at the center and this angle here. So which means the angle at the center, which is 180, is twice the angle the same arc subtends, at the circumference. So you see how this relates so much to the previous circle theorem. So even if you can't remember this, your mind should go back to the first theorem. It will help you to remember this circle theorem. So I'm just going to write an example and we'll end with this circle theorem. In the next lesson, we have other theorems to deal with. Make sure you are present, and for you to be aware that I'll be coming live, you have to join my community. So after this lesson, make sure you click the link on my bio. It will take you to my community, WhatsApp, Telegram, the WhatsApp group. There's my WhatsApp channel, and also there's my Telegram channel. Anyone you want to join, you are free to join. So let's just take an example, and I think we're going to end it here. Let me take this off and draw a circle. Okay, this should be very easy and interesting. If O is the center of the circle, find x plus y. So what that means is for us to get angle x and then get angle y, then add the two of them. I just explained angle in a semicircle. They told us that if O is the center, if this is the center, then the line that passes through the center has to be what? The diameter. And from what we know about angle in a semicircle is what? 90 degrees. So we can simply say that, see, from here to here, if you from the end point of the diameter, if you join it like here, the angle formed is what? 90 degrees. So x is equal to 90 degrees, y is equal to 90 degrees. In bracket, angle in a semicircle. You see, when you are solving this question, you must put the reason why you are equating two angles, or you are making an angle equal to a certain value. You must put it in a bracket. The angle at the center, or angle in a semicircle, or any other one that we will be treating in the future. So they say we should find angle x plus y. X plus y will be equal to, what is x? 90 degrees. What is y? 90 degrees. And when you add these two, you get what? 180 degrees. Okay, we have come to the conclusion of this. We have come to the end of this lesson. I don't know whether you have any question. Please drop it in the comments. Maybe I'll just spend like 2 to 5 minutes answering any question that you may have. But if you do not have any question, then we'll have to end the lesson here. Like I said, kindly head on to my bio and you'll see a link that will take you straight to my WhatsApp channel or my WhatsApp group or my Telegram channel. Do well to join any of those communities and you will be well informed when I come live. If before we have our next class, I would have sent a message reminding my students that I'll be coming live. I'll give like a day notice, so you'll be well prepared for the lesson. So in the next lesson, we'll be talking about different other circle theorems, like the opposite angles of a cyclic quadrilateral. You don't want to miss that lesson. We'll also be talking about, but again, there are many others. We'll be talking about angle in the alternate segment. We'll be talking about the angle, only the alternate segment, opposite angle of a cyclic quadrilateral, and several other circle theorems. Yeah. Any question before we end the lesson? We'll also be talking about angle, an exterior angle to a cyclic quadrilateral. Yeah. Okay, thank you for your time. Hope to see you in the next lesson. It's bye for now.